Hello everyone. Today we solve a Diophantine equation. Let's ignore this weird definition of interesting numbers and go directly to the problem. Let n be a positive integer. Prove that x to the power n plus y to the power n equals 2022 has no positive integer solutions for x and y. Before we dive into the problem, let's have a quick review of the major techniques for solving Diophantine equations. The first method is to use a bounded range for solution. If the solution has a bounded range, then within the range, there are only finitely many integers. So we can check all the integers one by one to get things done. Secondly, we can do factoring. If the polynomial can be factored, then we can look at each individual factor and study all possible cases. Thirdly, we can also use the module with respect to certain integers like 2, 3, and 4 to study the property of the equation and to narrow down the range of the solutions. All these techniques will be used for solving these equations. The first question, how big can n be? The equation x to the power n plus y to the power n equals 2022 for positive x and y. To answer how big can n be, equivalently, we may want to ask how small x and y be. We know x and y cannot be 1 at the same time. So the smallest possible integers would be 2. And we know 2 to the power 10 is 1024, and 2 to the power 11 is 2048, which is already bigger than 2022. So n must be less than 11 strictly. So now all possible n would be from 2, 3 all the way to 10. There are a total of 9 choices. It looks like that we have to solve 9 different Diophantine equations separately, but actually things not that bad. And let's go to the first case, n equals 2. X squared plus y squared equals 2022. We look at the equation in mod 3. First of all, 2022 is a multiple of 3. Secondly, we look at each individual square. So every square of an integer, when divided by 3, the remainder can only be either 0 or 1. It cannot be 2. You see, 0 squared is 0, 1 squared is 1, 2 squared is 4. When divided by 3, we got remainder 1. So either 0 or 1. Similarly, another square has remainder 0 or 1. Now, when we sum up the 2 squared, how can it be a multiple of 3? 0 plus 0 is a multiple of 3. 0 plus 1, no. 1 plus 0, no. And 1 plus 1, 2, no. So the only possibility is both x and y are multiple of 3. Now, if both x and y are multiple of 3, then their square must be multiple of 9. On the other hand, 2022 is not a multiple of 9. This is a contradiction. Therefore, x squared plus y squared equal 2022 has no integer solution. Let's have a quick summary here. We just proved x squared plus y squared equals 2022 has no integer solutions. Then for any positive integer k, x to the power 2k plus y to the power 2k equals 2022 has no integer solution. So in other words, if n is any even number, there will be no solution. Now we have only 4 remaining n to check, n equals 3, 5, 7, and 9. Let's go to the next case, n equals 3. X cubed plus y cubed equals 2022. For this case, I'm going to use the factoring. We know x cubed plus y cubed can be factored as x plus y times x squared minus xy plus y squared. Now we have a product equals 2022. Starting from here, we can definitely look at all the possible factors of 2022 and do a case work. That is definitely doable. But for this problem, we have a shortcut. We know 2022 is a multiple of 3. Then x plus y, one factor, and x squared minus xy plus y squared, another factor. These two factors, at least one of them, should be a multiple of 3. However, when we calculate x plus y squared minus the second factor, x squared minus xy plus y squared, we ended up with 3xy, which is a multiple of 3. That means x plus y squared is equivalent to x squared minus xy plus y squared with module 3. Combining these two facts, we conclude that if one of the factors from x plus y and x squared minus xy plus y squared is a multiple of 3, then the other is also a multiple of 3. In this case, their product should be a multiple of 9. And we know this is a contradiction. So there's no integer solutions for the case n equals 3. Let's have a quick summary. We just proved x cubed plus y cubed equals 2022 has no integer solutions. Therefore, x to the power 9 plus y to the power 9 equals 2022 has no integer solutions. Remaining n to check, 5 and 7. Let's look at the case n equals 5. X to the power 5 plus y to the power 5 equals 2022. This time, I'm going to study the range. Without loss of generality, we assume x is the smaller one between x and y. They are both positive integers, so x to the power 5 is less than or equal to y to the power 5. So y to the power 5 should be at least half of 2022, which is 1011. So y to the power 5 is between 1011 and 2022. We can easily check 3 to the power 5, 4 to the power 5, and 5 to the power 5. Only one integer 4 is within the range. So the only possible value for y is y equals 4. Then x to the power 5 would be 2022 minus y to the power 5. We got 998. However, the fifth root of 998 is not an integer. So no solution. We have another case for n equals 7. We can use a similar argument. This is all I have today. Thank you for watching.